Hello, my algebros. I want to just help you with some of these ideas of how to solve when we're dealing with congruent shapes, right? So when we deal with congruent shapes, we have this little squiggly line that represents that they are congruent. So that means that even though one might be bigger than the other, the sides that are matching to each other are congruent. So if I look at triangle 1 and triangle 2, I can see that B will match E, and C will match F, and A will match D, right? And these are our ratios or our proportions. So as long as we know at least one ratio side, we can solve for any of the missing sides. So if I have this triangle, RST is congruent to BCD, then I have to just look at them in order. We know that RS will be congruent to BC and ST will be congruent to BD, because when they're in alphabetical or not alphabetical order, but they have to match each other, right? So I can see on here that I can solve for the missing side because I match the little and the big. So the little is 8 feet on the blue side, and then we have a missing value for the same side on the bigger. And then on the lower leg, we have a 5 on the smaller and 12 on the bigger. And then we can use our proportions to solve for that missing side. And this really works with any shape, right? So if I have these kind of rectangles, and it tells me that ABCD is congruent to WXYZ, then I know the sides AB are congruent to XY, right? So these two match each other, as well as these two match each other, and these two will match each other, and so forth, right? So because I know that I have to match the side. So I know AB matches WX, so that is a proportion. And then DC matches ZY, and that's my other ratio or proportion. I cross multiply to solve. And so I can solve for any missing value as long as I have one good ratio set. You can try this try and see how you do. Oops. If you are wanting to practice a little bit, right? Hopefully that helps you with that last puzzle that we did. Okay, talk to you later. Bye.